Hello. Okay, so my goal for you today is to be able to find the x and y intercepts of a linear function in standard form or y-intercept form, and I want you to be able to graph them. So here we have an equation in standard form. If we wanted to graph standard form, to be honest, I would use the intercept method, which is what I'm going to show you in a few minutes. However, you can solve for y, get it into slope-intercept form, and put it in the y equals on your calculator. Okay, so I make sure I show you this, although it's not the main focus of the lesson. So our goal is y equals mx plus b. Y equals mx plus b. And I write that over top to give you the kind of geographic goal. Like if I write it this way, then the y is in the right place and the equal sign is in the right place. But we got to move some of these other things around. Like the 2x should be over here by mx. And 15 should be over here, and there can't be a 3 in front of the y. So we have to take care of all of these things. Okay, so first of all, to get y equals mx plus b form, I'm going to move the 2x over to the other side. But I can't just move something. I can't just pick up the 2x and lift it and put it after the equal sign. If I want to preserve equality and move something from one side to the other, then I have to do the opposite operation. Okay, so I take it off of the left-hand side, and I get 3y. And I take it off of the right-hand side to keep it equal. However, can I really subtract 15, take away 2x? No, I can't. Because they're not like terms. Well, if I keep my goal in mind of mx plus b, by the way, that plus could be a minus sign also, I should write the 2x first, and it's a minus 2x in the middle of a problem up here, but once I put it out in front, that minus becomes a negative. And this is a positive 15, but now that I'm tacking it onto something, it becomes a plus sign. Okay. So I'm getting closer to my goal. I have the y where I want it, I have the x term where I want it, and I have a constant where I want it. However, I still have a 3 in front of the y, and I don't want that. So I have to divide it to get y equals negative 2/3 x. Okay, see what I did there? I put the negative out in front, the x on the other side, and the 2/3 in the middle. 15 divided by 3 would be 5. Now the 2/3 I could leave as a fraction. I could divide it out and make it negative 0.6 repeating. It really depends on the situation which I would choose. And then I could take this equation, if I wanted to graph it, put it in the y equals of my calculator, go to the table, and use the values in the table to graph. Okay. Well, you can do that. That's one thing you can do. However, there is another method of graphing something in standard form. So we have standard form. Okay. We're going to talk about something called intercepts. I want to turn this on. Okay. Intercepts, the x-intercept and the y-intercept. You guys are already really familiar with the y-intercept. It's where the line crosses the y-axis. It's the b in y equals mx plus b. The x-intercept is the same thing as the y-intercept, except it's on the x-axis. And when you have standard form, those things are easy to figure out. Okay? So if we take that same equation, 2x plus 3y equals 15, and I want to graph it using intercepts, okay? Looking back up here at this picture, and I got to scroll up a little bit, okay? The y-intercept has coordinates of x is 0, and the y is the number that it's on. An x-intercept has an x value where the dot is on the x-axis and a y value of 0 because it's right on the axis. So another way of graphing and this works beautifully. You can do it with slope-intercept form, but it's really meant for standard form. You can find the x-intercept and the y-intercept. Okay. So if I was doing the x-intercept, that would mean that the y value is 0. So if I subbed in 0 for y, 3 times 0 would be 0. So that would effectively eliminate that term, and I would just for the intercept, not for all values. Okay? And I would really just have 2x equals 15. Divide both sides by 2, and x is 7.5. Then to write it in coordinate form, it would be 7.5, comma, 0. And I'm just going to draw a really rough graph over here of this. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Here's 7, here's 8. .5 would be about there. So I'd put a dot there. Then I'd do the y-intercept. Same kind of idea, except now I'm saying, all right, the y-intercept is when the x value is 0. So if I put a 0 in place of the x, 2 times 0 would be 0, and effectively that term is no longer in consideration. So we'd have 3y equals 15 left. Divide both sides by 3, and y equals 5. In coordinate form, it would be 0, comma, 5. Now, how do you know where to put the 0 and where to put the number? You go by the letter, okay? In coordinate form, y is the second number, so I put the 5 where the second number is and the 0 for the first number. In coordinate form, x's are the first number, so I put 7.5 in the x position and then comma 0. All right, so y equals 5 and 0, 5 is our intercept. Okay, here's 5, and I'd put a dot on there. Okay, I got 2 dots. Now I can just connect them. And write the equation on the line. 2x plus 3y equals 15. Okay. This equation is about nothing specific, x and y. You're allowed to have positive and negative values for x and y. Therefore, we can have arrows that point in either direction. Now, in our textbook on Friday, we started talking about the situation of student prices for tickets being $5 and adult prices for tickets, I don't even remember what the event was. And the goal was to raise $3,000. So this is the equation we were working with on Friday in our textbook. Okay? And we're going to use this same process. But in context, what the intercepts would represent is the situation where all the tickets that were sold were student tickets, or all the tickets that were sold were adult tickets. Okay? Now, it is unlikely that you would sell all student tickets. It is unlikely you would sell all adult tickets. It's the graph we're going to draw is to represent all of those points in between. Okay? So here, now, how do you know which one's x and which one's y? Well, it's not like independent and dependent variable where one of them is time and it's really clear which one is independent, which one is dependent. Generally speaking, once you have an equation, whatever letter is first would be the same thing as the x-axis, and whatever letter is second would be the y-axis. Okay? So if I'm finding the x-intercept of this graph, of this equation, I am looking for the situation where it's all student tickets. If I'm finding the y-intercept, it's all the adult tickets. Okay? So I'm going to leave this up here for a little bit. Okay? So remember, if we're selling all student tickets, I'm selling no adult tickets, and we're effectively ignoring the 10A. So 5S equals 3,000. Divide both sides by 5. If I was going to make my whole 3,000 on student tickets, I'd have to sell 600 of them. And in your textbook, it wants you to graph that. Okay, here's the student tickets sold, adult tickets sold. 600 student tickets sold if it's just student tickets. Uh-oh. Oh, there we go. All right, if we're selling only adult tickets, $10 a ticket, divide both sides by 10. We'd have to sell 300 of them. So we put a dot at the 300 for adult tickets. Now watch what I'm going to do here. I'm going to connect those dots. That line represents all the possible combinations of student and adult tickets that would result in $3,000. Okay? Notice I did not extend this line all the way to the edges in either direction. That's because if I did that, I would have negative values for student tickets, and you can't sell negative tickets. Same thing down here. If I extended this, I'd have negative values for adult tickets. We can't have negative tickets sold. So I did not extend the line. I started and stopped at the intercept. So be careful. If your problem is about something specific, ask yourself if it really can go on forever. Okay? Now, as a matter of interest, just so that you're aware, it's not really in your homework, but anything above that yellow line is still a possibility, or above the purple line in the yellow zone. That would represent they went over $3,000. They sold enough tickets to go over $3,000. If they were under the purple line, that would indicate a situation where they did not sell enough tickets. The purple line represents exactly $3,000 worth. Okay, let's look at homework for a second. Okay, somewhere in between there. Oh, all right. Number 20 and 21 are examples I'm going to do. Number 20 I want you to notice is standard form. Something x plus something y equals a constant. So I'm going to find the x-intercept and the y-intercept. This section does not involve any graphing though. We're just finding intercepts. So the x-intercept would mean that the y value zeroes out. 15x equals 270. Divide both sides by 15. And x equals, I'm going to have to type it out on the calculator, 18. Okay, so my x-intercept, remember x value comes first and then a 0. Okay, that would be my intercept. My y-intercept, again, that would mean that x is 0. So 3y equals 270. Divide both sides by 3. Y equals 90. 90 is a y value. That's the second number. So that would be my y-intercept. And that's all this section is asking you to do, is find intercepts. Now 21 is a little bit different because they give you slope-intercept form. I still want you to find x-intercept and y-intercept. However, did you notice? I'll say it one more time. This is slope-intercept form. That's because the equation actually tells you the intercept for the y-intercept. Okay? 0, 168 is the y-intercept. I don't actually have to figure it out. I do have to figure out the x-intercept, and it's a little different from number 20. Okay? So the equation is y equals 8x plus 168. I'm trying to find x, but I'm finding x when the y value is 0. Okay, when we were finding it in number 20 and we said the y value was 0, it means it got rid of that term. But now the equation is arranged differently and we can't just have it go away. Okay. Well, what's left is a basic two-step equation. It's kind of weird that it has a 0 in it. We're not used to using 0 too often, but I can still solve it the same way. Minus 168 on both sides. 8x equals negative 168. Divide both sides by 8. And I got to scroll this down a little bit. X equals negative 21. Okay, so there's my other intercept. So it's a little more work for the x-intercept, but no work for the y-intercept. Okay, then in the next section, you're doing the exact same thing, except once you find the intercepts, you're going to plot them on the graph. Now, sometimes you might have to choose how you're going to number your graph. You might not be able to number graphs by ones. Okay, and just be careful how you number things. You should be, a good rule of thumb is to, when you're numbering a graph, think about money currency. Okay, and what does money count by? For example, do we have a 17-cent coin or a $17 bill? No, that's because counting by 17s is hard. So we don't want graphs that count by weird numbers. We want graphs that count by things that we would have money for. Okay, now ones, we have a dollar bill. We have $2 bills. We don't use them very much, but they exist. Even counting by 3s and 4s isn't that bad because it's a small number. We have a $5 bill. Okay, the next thing I would recommend counting by is 10. Then maybe 15s. Even though we don't have a $15 bill, it's still reasonably easy to count by 15s. 20s, 25s, 30s, 40s, 50s. You know, things that are easy to count by. Do not count by weird numbers like 17 on a graph, ever. Okay. I hope this has been helpful. You have a quiz tomorrow, and have a good night. Bye-bye.